So why do I ask about change agent? Because I believe we need to change something about how we think about backup and disaster recovery, which is the reason I'm standing here, to share my thoughts and get your feedback. And this is indeed an interactive session in that sense. Please do raise your hand, interrupt me if you feel you need to ask a question or want to add a point. I don't mind that. I'm happy if we actually have a conversation. I do need to apologize because I will stuff you a lot with ideas, and I'm sorry that cannot be avoided because this is a super heavy and important topic which we unfortunately have to take care of. So I guess you all have more or less some sort of operational responsibilities, either yourself or in your company, or you have friends who are responsible for operations, or you have business responsibilities. So that's why it might be interesting to follow the story. Okay, 11:45. Welcome to my second talk at this conference about backup and disaster recovery. Yesterday we talked about the no restore solution, which I will briefly mention here. Today we talk about the bigger IT strategy perspective on backup and disaster recovery under the headline business as usual, or what needs to change now. And why now? Well, because the era of cloud and SaaS is not only here, it's already active, and we all use cloud and SaaS. And I believe that there are several core, like root cause problems in how we need to think about backup and disaster recovery that we need to change. Quick introduction to the basics. Obviously, backup, restore. It's important that we talk about the same stuff. I will briefly mention what happens in the data center. Who here has a data center? Oh, nice, nice, nice. It's still relevant, by the way. I found 8 challenges, but I might have miscounted, could be more. I have some ideas that we can implement to face the new reality, and I hope that your backup and disaster plan looks better than that. This is like, yeah, I don't know. They look happy, but I'm not sure they're happy there. So, business continuity, quick recap. In my opinion, this little story tells it all. In other words, staying in business no matter what. And for me, business continuity is always a holistic problem, from the very top of the company till the very bottom, like encompassing everything. All business units, all domains, all departments, everything together has to contribute to business continuity. You cannot think about business continuity as a siloed problem or a layered problem in the infrastructure or in the data center or on your storage. That doesn't work. It's a holistic problem, and you need to look at it end to end. So let's have a quick look at a typical timeline of a disaster. So we don't have a disaster, we start from backups, right? And then we take another backup, obviously, eventually. And then we take another backup, but something blows up. And trust me, it will blow up while your backup runs, and it will destroy your backup so that you only have this backup to rely on. But what you'd actually do is headless chicken mode to recover some part of your systems. Then you do a bit more organized chicken and less headless. And then you eventually have a mostly recovered environment. And this is quite normal. We all do that. We all live in this world. What's important to remember is that the recovery point objective is the time that we travel back into the distant past as we use an older backup, or how old is the recovery data. And on the other hand, the time from the big boom to some sort of recovered system is the recovery time objective. So how long does it take us to recover? And obviously the total time of the outage is both of it, plus a lot of manual cleaning up, whatever. Or in other words, how to remember it, this is what we have in our pocket. Yeah, you have it in your pocket, on your backup tape, whatever. You can actually act with that, and the RTO is what we actually do with it. So have and do are the key criteria for any thinking about backup and disaster recovery. What do we have and what can we do? So, very important. Backup is not disaster recovery. It is not the same. It is fundamentally different. If you look at backup, I would say actually backup doesn't matter. I care about restore. And you will see how I more and more talk about restore capabilities and not, oh, we have a backup, because I honestly don't care about backups. I care about restores. So restore is single something, single file, mailbox, database, LAN server, whatever, single something. And disaster recovery is the opposite. It's all of it. All the files, all the mailboxes, all the databases, all the servers, all the LANs, everything. That's disaster recovery. And that's the fundamental difference between these two worlds. And why is that important, or what makes it so different? So restore happens when we have the file server and we restore a file onto it. So it's always restoring a small piece into an existing bigger envelope. But disaster recovery is when we don't have the server, the storage, the network, or the data center. And most of all, disaster recovery happens guaranteed when we don't have time. And that's the problem here. Restoring something is not a problem. Our backup tooling can handle that. The interesting question is disaster recovery. Everything is gone. What do? We don't have time. What do we do? So I would suggest 3 guiding principles that should help us to navigate these waters. Number 1, backup is the means to enable restore. Don't talk about backup. Nobody gives about backup. Talk about restore. The ability to restore requires having a certain type of backup with a certain quality that will facilitate the restore. A comprehensive backup and restore automation please, is the means to enable disaster recovery and business continuity because of scale. Remember, we go from restore single something into restoring everything. It's a scale out problem. So the way how we handle scale is automation. That's why automation is key to success here. And finally, please use the same backup, physical backup for restore and disaster recovery. Try to find an architecture, a technology, a solution, a plan that will avoid having a backup for restore purposes and yet another backup for disaster recovery purposes. Why? Expensive, redundant, unnecessary, set up for failure. How do you test it? So a quick look at the data center. A typical data center architecture looks like this, and this is true since I was small until today. You have a bunch of hypervisors, and they all connect to typically a central piece of storage, and then you have a bunch of virtual machines on that, big, small, green, blue, whatever. And you have a bit of hardware next to it for stuff that doesn't like to be in a virtual machine or where people don't trust it to be in a virtual machine. And obviously, you have a backup system that hopefully connects to a backup storage and maybe even a tape drive. This is the typical archetype data center architecture. And everybody who has a data center has something like that. Or if you are a bigger organization, you have it in the fancy version, which is extended on 2 sites or 2 rooms or whatever. And the minimum version is you put the backup and some hardware in the other place, and maybe a bit of hardware that you can use to recover your most important workloads. And by the way, this is a very simple architecture that allows you to do a disaster recovery here, partial disaster recovery, but quickly, in case the data center on the left is gone. So even a stretched architecture like this has a lot of benefits and solves a lot of challenges. And very important here, the key components of this architecture, all important data is in one place. And that makes it easy to back up, central backup. And we accept crash-consistent snapshots as the backup. And these are kind of things that we accept. And in this scenario, backup is a platform service. This platform provides backup for everything and restore and so on. Standard architecture, right? Everybody feels at home here who has a data center? Yeah, well, that's like our home base. So quick recap, backup 1, 2, 3. We need to have 3 copies and so on. So we have a primary storage. We use that to create snapshots. Snapshots, yeah, are in the same storage, just a different copy, and then we copy that over to some other place. We call that replication. And then we copy that again onto offline media. And for me, these are the three means to reducing RPO, snapshots, replication, and offsite backup together. And that's the standard way how to implement the backup onto three. If you don't have that, get going. This is like old school. You should have that already. Let's talk about the new problems. So, first challenge, consistency, right? And what does it mean we have a consistency challenge? Consistency between what? So, applications typically don't run on a single system nowadays. They run on many systems. Applications assume, and this is an implicit assumption of all applications that you operate anywhere, that everything is consistent when they need it to be. Like you have an ERP which absorbs files, puts them into a file share, and writes a record into a database. Your ERP software will implicitly assume that the data in the database and the data in the file share will never diverge. They will be always consistent. Or your application deals with multiple databases. It will implicitly assume this is somehow consistent and nothing can go wrong. And a database is never offline while the other one is actually online. And I remember times when we actually shut down databases because some other database had a problem and we needed to shut down the other databases to prevent a divergence in our data. Yeah, think about that. The other problem is we have multiple applications. Yeah, the days of single application per company are long over. So you have multiple applications, you have business transactions that span multiple applications and multiple steps, and very often they are not even implemented in a transactional fashion, like, database rollbacks and all that. They just, fire and forget, the world will be good. And business transactions can take a long time. So what happens if in one half of the company the transaction actually happened and in the other half they never heard about it? And then you have the outage and then you restore something. After restoring something, did the transaction happen or not? It's a huge problem of data consistency. And I believe this is a problem that we need to solve. The solutions, unfortunately, are really, really hard because the solutions are, and you don't want to do that, stop all services, take your backup, start again the services. You probably don't want to do that. Better is you find the inconsistencies and rebuild company-wide consistency via some automation. Who actually implements that? Thank you. I don't know anybody who does. But that's what you should do, actually. And what we all do is ignore the problem and hope for the best. Yay. It's called a strategy. And then you write it into your risk acceptance for your ISO certification, and everybody's happy. The next challenge. I told you, I will stuff you with problems. I'm really sorry about that. So I call it the restore time objective challenge. And the real challenge of this is actually the time. And the problem with time is it's too short. Same like I don't have enough time for all my talks. The time you have for the actual disaster recovery is probably too short. And let's look at a specific example, and it's super simple. Imagine 140 terabyte SaaS storage. We're still in the old data center world where everything was simple. And it fails, and you recover it. You can do the math. You won't get below 5 days recovery. No way. From a full catastrophic SAN failure, no faster recovery than that is possible. The question is, will your company survive that week? What do you do with your external communications? People ordering materials and you don't even answer them. People think your company went away because your website is down and so on. And what happens if all other things that you have also got encrypted by the same ransomware and you don't have a plan for that? And my favorite, how do you test and validate these projected 5 days? Because there won't be 5 days, they'll be much longer. Yeah, here in Berlin, we had a hospital get ransomware hijacked and they were out for like months. just like that. And nobody then talked about the cost of backup and disaster recovery. They all cried that they didn't have good stuff. So what's the SLA? The SLA is RPO and RTO and a lot of prayer and hope. How do we fix that? And I said we want to fix the RTO problem. So we fix the RTO and hope and pray part because the RPO is a different problem. And if we fix the biggest problem and unknown, the RTO and pray and hope part, then let's say, okay, let's get rid of the restore time. And let's exercise the restore every time instead of just, once a year or maybe never. So getting rid of the restore time and exercising it, that's the key to success here. We just restore every backup immediately. We validate that it actually works. We will have a replacement system that is ready to use. So instead of trying to restore something, we actually recover via switching over to a recovery system that already works. We did all the recovery and the testing and validation beforehand, before we needed it. And that's how you get a fixed RTO without any hope and prayer involved. So I call that the no restore solution because it eliminates the restore from the actual disaster time. It doesn't eliminate the restore from the architecture, but from then when it hurts you. And that's the trick. So going back to the example, we have a backup, and then we don't take another backup, but we automate the restore. We check the result. And then we have a recovery system that actually works. And that's the trick here. And then we take the next backup, which of course again blows up, but we already have a recovery system that works. We just switch over to that and we're done. And that's how you get a fixed recovery time regardless of the size, dimension, complexity of your environment. I call that the no restore solution. It's a mindset and architecture pattern that you still need to implement in your environments. You can watch yesterday's talk to see more specific examples how to do that. Let's talk about the next challenge. Sorry, lots of challenges today. The regulatory challenge. And what's the problem here? We have laws and they say, thou shall do this and this. Yeah, so they just dump requirements on you from outside, and if you don't fulfill them, then you are with one foot in jail, at least your bosses. That's the problem of the regulatory challenge that we need to solve. And we are in Europe. We have an abundance of regulation. You can try to decode all the abbreviations here. And I would coin an 11th commandment to summarize all of that, which is, thou shalt build thy works upon a foundation of order, that in calamity they may be swiftly restored. Or in other words, just take care of the hard stuff now. Because that's what we need to do. We need to finally solve all the hard problems that we always pushed away and didn't really deal with, like automated disaster recovery. The technical debt that you're carrying around as a luggage. I have also luggage, so I'm trying to get rid of that. Think of it like that. Do the necessary health measures to be able to recover from outages in the required time, and you will be fine and compliant. So looking at a short summary of the relevant regulations, and I just took KRITIS, BSI-Gesetz, NIS2, which is a European directive, DORA, which is also a European directive, and GDPR, which is also a European directive, as an example, and I tried to extract what actually applies to backup and disaster recovery. And it's a lot. So here we have a little community exercise, which is a compliance self-check. Let's play a little game. I'm assuming all of you fall under that because all of you at least need to take care of GDPR, correct? Probably a lot of you have also other regulations that you need to be aware of. So let's everybody raise a hand and play a game. Come on, guys. It's before lunch. We still have a bit of energy left. Come on, everybody. Hands up, everybody. Hands up, everybody. Come on, gonna be fun. So, self-check regulatory requirements. Everybody who has comprehensive backups, keep their hands up. Very good. Everybody who has comprehensive documentation for that, keep your hands up. Ah. There are prizes to win. If you get to the bottom of the list, there are prizes to win. Okay? Stay in the game. So, did you do a business impact analysis? It's a regulatory requirement, by the way. Very good. So I still see some hands. Do your recovery times actually match your business requirements, especially for a complete site-wide outage? Nah. Sorry to lose you. Do you have a proven restore and disaster recovery capabilities? Proven, not believed, not claimed, but proven. Very good. I still see some hands. Thank you. Do you have regular exercises of abilities and procedures?
More than once a year.
At least once a year. Okay, very good, very good. Do you care about third-party solutions? Which is a regulatory requirement. It's in the text, Article 24 of DORA. You need to take care of third-party requirements. You're responsible for the operational resilience and recovery capabilities of your third-party vendors. Okay, still some hands up. Very good. And you need to have exit strategies for all your third-party vendors. Okay, how many hands are left? 2. Thank you. I printed 3 giveaways. Because you are now certified 100% and you get this to take home. That's the other side. So come in the end and take your personal certification for your self-check regulatory requirements. Well done. Thank you very much. But you see how hard it is. You see really how many things you need to do in order to be compliant in Europe. And I don't believe other regionalities are that different. Okay, the next challenge, cloud and SaaS. So what's the challenge here? There's so many, you can't really catch them, right? Did you ever try to catch clouds? I'm willing to bet none of you has a precise understanding of how many cloud and SaaS offerings your company actually employs, including all the employees, including all the free services where they just signed up with a company email without paying for it. Willing to bet. So, the problem is decentralize everything. We start from our data center, which didn't change, but then we keep adding a lot of more things. Let's call them cloud and SaaS. It's sort of the same, different flavor, different kind of interface. But in the end, it's the same story. It's not your computers, it's other people's computers. And there's just a gradual difference between cloud and SaaS. And the question is obviously how to recover all of that. What do you do with it? Right? It's a big question. And remember the consistency challenge? Here it comes back. So there's the decentralized consistency challenge. Imagine we have just these 4 pieces of environments that we take care of. Data center, cloud, SaaS, doesn't matter. Different disconnected areas where business transactions happen. And for fun, we add queues because we're modern, right? We all love modern architecture, so we have all this asynchronous communication going on. You're laughing. There's a problem with queues. You know what? The problem is in the queues. So question number 1 is, how do you actually synchronize backups across this entire diverse, globally spread landscape? Right? You don't. But it's a problem because what happens if a transaction starts here, does something, goes there, comes back here, and then the transaction is like 30% done, and then it booms. But the backups, they are kind of all different. And what happens to the data in transit, the data in state that is in the queue waiting to be processed? Because we all use queues and assume they never go away, and the data in the queues never goes away, and. And nobody backs up queues, ever. Right? Anybody here backup scheme for queues? No. What for? It's a queue. Yeah? Shit in, shit out, whatever. These architectures are super nice for decoupling stuff and super hard for consistent recovery scenarios. So we're back to the application architecture needs to solve it. We can't do it in infrastructure. And that's the thing. The more we go into cloud and SaaS, the more the application architecture has to own these problems. Next challenge, sorry. The infrastructure as code challenge, please.
Can I ask a question?
Of course.
So Kafka is also considered a queue?
Yes.
Is there anybody here in the room that is using backup of whatever happens in Kafka?
No, are you kidding? So the question was, anybody backing up Kafka? I can guarantee you nobody's doing that. Never heard of it.
Thanks.
Not saying it's good, it's just saying that's how it is. Your application architecture needs to handle reconciliation of diverged, disjunct pieces of data that came back after an outage. That's the job of the application. So, infrastructure as code, you all do that, right? Nobody is doing manual ops, click, 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 click on some cloud console, hopefully. Let's all assume you do infrastructure as code. So what happens? We have people who put stuff into Git repositories, who then go into some automation, running without people holding its hands, that eventually puts stuff into runtime environments, cloud or on-premise, right? That's the big picture. So what's the challenge? You back up your Git. Who doesn't? Please back up your Git. It's important. Then you back up your CI/CD infrastructure as code, whatever, delivery automation. Then you back up your data that actually runs in the runtime. Correct? You're good guys, you do that. And then you recover it. Did you try it? Did anybody ever try that recovery scenario? Did data, code, and config actually fit together? What happens if you have here a Kubernetes cluster and you restore this cluster, like etcd, we put everything back. And then we have our Git stuff and put that back. Does it actually fit together? Can I make a Git commit change and it will run through and be happy? Yeah, so I can guarantee you this won't work. Because it's the wrong pattern. This is the wrong pattern, and that's the ISC challenge. So what's the solution? The solution is you need to instrument your ISC for the entire problem domain. So you take a backup, and then you restore the backup in Git, and then you use that to restore the backup for your CI/CD, use that to restore the backup for your actual workloads. And here's a guiding principle. Everything gets deployed via the same tooling, right? So having a backup get restored not via the same tooling would be a violation of this principle. So we need to use the same tooling for the entire life cycle of our applications. That's why it has to go through the front door, not the back door. Backups from beneath are like backups and restores through the back door, and that doesn't work well. Doesn't scale, is not consistent, and you don't actually control it well. So I believe the application, whatever that is, needs to have a bit more of infrastructure operations responsibilities, like deploying code and config, obviously, but deploying a backup tool that understands its data and restoring data if it's missing, and ensuring consistency, the hard part. And please automate restore and recovery. It's an end-to-end problem that needs to be owned by the application. And then you will get into a scale out, scale up, stay happy world where your applications own their entire life cycle, including backup, disaster recovery, continuity, failover, and whatnot. And that's the important part here. It's owning end-to-end the problem space. Next challenge, please.
On which level you were talking about that using the same tooling for everything.
Yeah.
But on a technical perspective, on which level would I be able to use, for example, the same tooling to roll out my CI/CD system as well as the data of my database backup? On which level would we be talking here?
I give you a simple example. Imagine you have an init container that knows how to restore the data if it's actually missing. And then when your Kubernetes deployment comes up, the init container says, oh, there's no data, but I have a space where the data should be. Let's restore the data from the last backup and then continue the process and start the application.
Okay.
That's, for me, an example of owning the problem space end to end. And just one example. You can invent as many as you want, and maybe that's not the right solution for a lot of problems. But the idea is the application owns end to end the entire problem space. The engineers who build the applications, they can understand the problem space end to end and optimize for it however they want. And they don't go into, wow, the platform does a backup. I don't care. It's not my problem. I don't know about backups. They happen. It's not true, they don't happen. So, the shattered restore challenge. And I invented that name. So, what's the problem with SaaS? The problem with SaaS is you don't own the identifiers of your data in the SaaS application. Say it again. You don't own the identities of your data in the SaaS application. Right? How does SaaS applications work? I give it some data. It responds with, here's a link for that, a URL. And the URL has a server-generated identifier. So, example, my Google Slides presentation has this uniform resource identifier. It has a code in it which represents the identity of my data. For illustrational purposes, imagine it's this Lego model. Then I have a backup. I delete it. I restore the backup. And I get this. So I get a different identity. Like, I can't restore into the same place, which in the Lego world means you go from having a Lego model to having a bag of Lego pieces. Because even though I might have all my presentations, the way how my data links to each other is broken. So I have a pile of data without interconnects. And there's no way how to solve that. There is no solution because SaaS vendors make it technically impossible to restore data as it was before, including referential integrity within itself. And this is, in my opinion, one of the major drawbacks of SaaS applications. They're designed for no restore. It's part of the vendor lock-in business pattern. Okay? Just think about that. Think about how many SaaS applications you use where you cannot restore data into its original location. And I'm willing to bet you have a lot. So, we come to the data possession challenge. And I'm sorry if I need to rush a bit. It's a lot of challenges, unfortunately. So, you all maybe have heard of this scenario. I all hope you've never met this scenario personally of somebody lifting the wallet from your pocket. What happens here technically is one side has ownership of the wallet and the other side has the possession. And ownership and possession is not the same, right? There's a fundamental difference, and it's important here, especially in the SaaS context. So imagine we have a SaaS application. Internally, the SaaS application looks like that because, SaaS vendors still cook tea with the same water. In the front, it looks like this, and then you're the user. And the vendor has some data, and my data in his platform, all mixed together, like multi-tenancy, if at all. So far, so good. The vendor has actual possession of my data because it's their hard disks, and I have ownership. I have a contract. So the contract grants me ownership to my data, but I don't have possession. I gave that up. So far, so easy, right? Does your vendor actually make a backup? Probably they do, but probably only for themselves. They will safeguard against technical failures, but they might not perform the backup for you. They might not give you an option to backup and restore data via a click on the platform. Right? That's the SaaS model, because they own the internal representation of the data. You have a question?
Yes. So the SaaS owner is also under the regulation, as you have mentioned before. And
Yes.
we are
No. The SaaS vendor is not under the regulation. You are under the regulation. You need to ensure that your SaaS vendors are also fulfilling the regulation, but they themselves are not under regulation. It's a slight but important difference. And you can't rely on SaaS vendors doing anything for you unless you try it out. So, what's the problem? Somebody might say, stop service, stop exporting data, stop, whatever, for whatever reason. The result is you don't have your data, right? Because the data is still there and you are here on the other side of the stop sign and you don't have your data. What do we do with that? Option one is you actually took a backup yourself in your own pocket, in your own on-premise server room, whatever. If you did that, good for you. The other option is you go to court, sue the vendor to give you your data, and maybe 10 years later you get it. Of course, your company already went out of business without the data, but that's a different story. And I believe this is a fundamental problem of SaaS vendors, applications, business models, that they don't really care about your data. So I call this the SLA challenge. Sorry, yet another challenge. Imagine a cook in a perfect kitchen cooking a very disgusting soup. And that's, by the way, the prompt I gave to Gemini. So what happens here is you're the cook. You're responsible for what you put in the soup, which is your data. And the SaaS vendor gives you the kitchen. The kitchen is perfect, right? So what happens in reality is the SaaS vendor doesn't care about your data. This is an example I took from Google Workspace, which illustrates the kind of distribution of responsibilities for IaaS, PaaS, and SaaS. And the problem is that all the hard stuff, like accidentally or maliciously deleting data or granting access to malicious players or apps, like how often do you, give a grant on Google or Microsoft to a third-party app to access your data? Every day nearly. And we don't even think about it. Or you delete a user or the tenant or the whole thing, or somebody hacks you and does it for you as a service. It's all honestly your problem. Because the SaaS vendor only guarantees technical operations and we don't care about your data. And that's the problem of the SaaS business model that we need to mitigate as an industry in order to be successful, because we can't do everything in our basement. That's just not feasible. We need SaaS. We need SaaS to be successful. We need SaaS to be reliable in order to continue as an organization, as a company, as a business. Like my company, we have 15 people. We can't operate IT in our basement. We use only SaaS because that's the only thing that's feasible for us. And I'm willing to bet a lot of you in this room are in a similar situation at a different scale. You cannot afford to solve all the problems internally. Way too expensive. So, some personal materials that I developed over the time. One of them is Relax and Recover, my Linux bare metal disaster recovery automation. Started a long time ago, still going strong. It's now the only meaningful tool on Linux. It's part of all the Linux distributions. If you run Linux servers and you don't use that, please talk to me. I'm happy to help you. Or just go to the homepage and do it yourself. A long time ago, a customer asked me how to make a double redundant file server, which would survive a SAN outage with his like 2-digit SAN storage and a hardware outage of the server. So we came up with a model. It uses virtualization and local disk as failover kind of means in order to ensure we can cover both an outage of the SAN storage via the local storage or an outage of the actual physical server via a virtual machine, like, crossover replacement solution. It worked really well for a long time. And I still think for some scenarios, it might be a good model. When VMware launched its VCB backup product, it actually implemented the no restore solution, but in a way that's not useful and not usable, because the virtual machines that you had in the backup couldn't be started. So I wrote a little open source tool that solved that and automated the process end to end, that the backup could be started on a hypervisor, and that was the first version of the no restore solution. I did a deep dive into Google Workspace backup and disaster recovery. It's a mission impossible, just forget about it. And same for Microsoft 365, forget about it. There is no full, complete disaster recovery. You just have to accept the loss if you lose the data. You can mitigate some problems. Look at this blog article. There are some practical approaches, solutions you can buy and install. And finally, I'm a big fan of test-driven infrastructure, especially for platform engineering. I invented that in 2014 under the headline of DevOps risk mitigation because people were afraid to give developers so much power in platform. Then we said, okay, let's use test-driven development as a way to kind of shift from trusting special people called admins to trusting code that everybody can write and contribute to. And that's actually DevOps. You trust code more than people. And then you get somewhere. So, the new era of backup and disaster recovery, a quick recap. Backup is hard, restore is harder, disaster recovery is even harder, but you still need to do that. And I wish for you all to accomplish it, even if it's hard. And I hope to give you some tools which will help you to accomplish that. Use the fixed RTO approach of the no restore solution to get predictable recovery times, and then iterate over that to be faster, better, whatever your business requires. Think about data consistency on a company-wide level, on a business transaction level, and mitigate it in the application architecture. Don't expect infrastructure to solve all problems because it can't. Infrastructure always has a smaller scope than your entire company, at least after the data center. Know your regulatory obligations because they really matter. And even though you might not be affected, your upper management actually is personally liable for doing that. Think about automated restore and recovery, automate everything, and beware of SaaS. There's no SLA for your data, no data possession, and no restore. And I'll be happy to talk with SaaS vendors about improving that, becoming better SaaS vendors by solving these hard problems for their customers, gaining a competitive edge for how to be a better SaaS vendor by solving the actual problems that customers have. And that will also help you to be compliant for your customers' regulation, which is super important to win their hearts and their business. Oops. And finally, we're at the end. I'm sorry if it's a bit late. We have time for a few questions. I'm also here a bit longer. Come to me, talk to me. Send me an email if you have questions. I'll be happy to answer with some infos and links to my materials. And you can check my homepage. Obviously, I'm a consultant, happy to support you as well. That's how the business works. I tell you ideas for free, you try them out, then you tell me what I can fix, or you just ask us to help you implementing them or developing better ideas. I'm doing quite a lot. I have too many hobbies, so to speak. Whatever we can help you with, we'll be happy to contribute, and thank you very much.